Hello everybody, welcome to CONDG. We're just getting started here. We're going to wait a few more minutes for people to show up, but hope you had a fun time with the trivia. Hope you got some of those right. And hey, hello there, Surly. So if you all have suggestions for future trivia questions, make sure to submit them there because they're getting a little stale. We could use some new ones, especially .NET ones, to represent here at CONDG. So let's see. I know we got Matt Eland, Integer Man, in the chat there. We got Surly Dev. We got Tahansen 43206 checking in. I assume that's a. I think we said this last month. It's a Ohio area zip code, Central Ohio zip code. So hello. Everybody else there, feel free to check in on the chat. There's benefits to hitting the Twitch chat, by the way. Even if you just say hi once, there's benefits to doing that. So go ahead and hit that there. And I'm going to go ahead and bring up this slide deck, which we'll start going through here in a second. So this gives you some time to, if you haven't already, go and join the meetup, go follow us on Twitter, Facebook, all that good stuff. All the information is there. Hey, Coding with Calvin. Calvin's checking in. How's it going, Calvin? I think I have all the bells and whistles turned off for Twitch right now. This is just going to be more of a straightforward presentation type of a stream. Let's see. I am Bert Pix. Howdy. I'm still on the notable people of Grove City. Yes, this was a stream last week. We were just joking around, and someone added me as a notable person from my hometown of Grove City, Ohio, on Wikipedia. So I'm still there. No editor has removed it yet. So at this point, it must be true. It's on Wikipedia. They must have been so desperate for someone to update that page. How dare you, Surly? That's my hometown of Grove City, right here in Central Ohio. Not named after me, by the way, just a coincidence. I got Sean standing by here on Zoom with his presentation. I've gotten a little bit of a sneak peek at it already. Looks like some cool stuff. So we're going to get through our sort of announcement slide deck here in just a minute or so. We'll start on that, and then I'll turn it over to Sean. I do want to say before we get started, I'll repeat this again, but if you want to ask questions of Sean, throw them into the Twitch chat there. If you don't want to create a Twitch account, that's totally fine. You're still welcome here to watch on Twitch. But I have the comments for this meetup are open at meetup.com. You can go to the URL there on the screen and leave your question there as a comment, and I will monitor that during the meeting as well. I also want to say, before we get started here, that I think they're on their way out, but I have some remodel work going on in the room next to me, so there may be some tools and hammering noises every once in a while, so sorry about that, but nothing I really can do about it. Let's see. It's not named after you. No, it's not named after Surly Dev either. And there are worse things to be listed on than Wikipedia. Yeah, there are worse things than Wikipedia to be listed on. But I just assumed that the Wikipedia eagles would swoop in like immediately and remove that spurious addition. But the Grove City, Ohio page must be such a low priority. It didn't do that. All right, well, it's 6:05 now, so I'm going to go ahead and start chucking through these slides. We got about 27 people in here, according to Twitch anyway. Who knows how accurate that ever is, but pretty good crowd so far. So let's get on with it. Even though we're not being there in person, I want to again shout out to G2O for being such great partners with us up until we have to stay at home. And hopefully we can meet up there again in the near future. They're not providing the space for these last three meetings, but I still want to give them a shout anyway and say thank you. And we have a raffle going on, just like the last few meetings. We have a license for JetBrains, and we have some Couchbase swag. I actually have it right here, lest I forget. So the JetBrains license is the grand prize, And it's a license to anything JetBrains makes, ReSharper, et cetera. For Couchbase, again, we have the last of these little robots, these little AT smart robots, little fun little toys there, kind of like a smart robot. And then that's second prize. And then third prize, I have another one of these fine quality notebooks with comes with a pen. And those will both get Couchbase sticker packs with them. Couchbase stickers and pins and whatever else I can throw in the box there. I did get a thank you note from last month's winner with a picture sent over. The prize ended up in the hands of this 6-year-old, and he sent this picture, and I asked if I could include it in the slides, and he said sure. This is one of his comments. He says he is very much into the math and engineering, abstract thinking, types of things. So any other ideas you have for a 6 to 7-year-old, very much appreciated. So if you have those ideas, throw those into the chat right there. Some ideas for younger kids to get engaged with math and engineering and programming and whatnot. Just throw them on in there, and those ideas will be lots of fun things to do and check out. We've already got a few ideas there in the chat. We got Scratch and edublocks.org. So those might be some cool things to check out. Some other user groups in the area that I think most of them, if not all of them, have moved their meetings to online as well. CO Azure, Central Ohio Azure Group. At last I checked, their meeting on Microsoft Teams or Twitch. Most of these groups are using Teams or Twitch. So you might want to check them out. That's coazure.org. The Columbus App Dev User Group, they are also meeting virtually. You can check them out at columbusappdevusergroup.com. And the Azure Group is, of course, about Azure and cloud type stuff, and App Dev User Group is about all things development, but tending their heritage is kind of like mobile apps and desktop apps, but they also cover all kinds of web and cloud and all kinds of technologies like that. And of course, the Buckeye SharePoint User Group. Someone needs to check on them, make sure they're okay. Not because of any world crisis, but because they're still using SharePoint. But you can go check them out. BuckeyeSPUG.com, see if they're still meeting. The PASS Association for SQL Server, Professional Association for SQL Server, I believe they are still meeting on a regular basis, and the many of the SQL Saturdays are still happening virtually. I think the Columbus one was actually canceled, not postponed, but canceled. But it may be coming up in the future, and they may be still meeting on a regular basis for their monthly meetings. So go check that out, columbus.sqlpass.org. And then the Let's Talk IT Columbus group. We had Seth Petrie-Johnson here last month, and I think he also attends this group on a regular basis. This is kind of it's a group for coders and technical people, but it's not about coding and technical topics. It's more about the other stuff that goes into business and IT. So definitely a different approach to user groups. You want to check that one out. They meet on a monthly basis as well. These are our upcoming meetings, the best of my knowledge. So tonight we've got Sean Whitesell all the way from Tulsa, Oklahoma, presenting on microservices. Next month was normally scheduled to be lightning talks, but we're kind of it's kind of a tough one because they're designed to help people getting started speaking, and it may just be asking a lot for people to do that for the first time on a stream, presenting right to a camera, and for our team to deal with the presentation of 5 or 6 different people. It's already difficult to do in person. So we're skipping this time. I'm sorry, that's a bummer, but we'll bring them back eventually. I'm optimistic we'll get them back at some point. So next up in July, being virtual now, one of the things that's easier to do, since everyone's staying at home, is that it's easier to get speakers from other states. So no one is off limits. And we're still planning, and we're making the assumption that we'll not be able to meet in person next month. So if you're an optimist, we might be able to meet in person soon, maybe not. But this is the schedule right now. If the speakers got them lined up, we're going to present them remotely and possibly even simulcast, if you're an optimist. If not, just, we're going to keep going on Twitch here, and that's the plan right now. So next month is A speaker that I've been trying to get to come to our group for a long time. It's Rocky Laka, and he'll be talking about running your business logic everywhere. We've tried to get him in the past, and it's just never really worked out, but we're finally going to get him to speak at CONDG. It's going to be very cool, so I'm looking forward to that. If you have any ideas for speakers, we've got a pretty big list right now of suggestions for speakers, but if you have suggestions for speakers, drop them into the chat here. We're looking for .NET or .NET adjacent topics from speakers, so just throw any suggestions in there that you'd like. Again, no one's really off limits. Closer to the time zone, the better. But now's an opportunity for us to really expand and bring in speakers from all over if you want to. I'm also perfectly happy to get some more speakers from the Central Ohio area here as well. Let's see, anything else? Okay, that's it. If you're looking for work, or if you're a company that's hiring, please virtually raise your hands by throwing it there into the chat. It's totally okay to do that and discuss that in the chat here. If you want to be more discreet about it, you're welcome to just email me. That's my email address right there, and I'll be happy to make that connection discreetly, kind of behind the scenes. So a couple people have taken me up on this, and I have made some connections so far. I have no idea if anybody's been hired or not, but I'm making those connections. So feel free to contact me at that email address, and I will just sort of act as your behind the scenes broker. But again, if you're comfortable using the chat, if you're hiring or looking for work, throw it right there in the chat. Totally fine and cool. We used to be able to drive across the street after CONDG meetings and go to hang out at O'Charlie's, have some snacks, have some drinks. We can't do that right now. If you're aware of CONDG's history, by the way, if you've been with us for a long time, you know that every restaurant we've gone to in the past for these has eventually shut down. I'm not making this up. And O'Charlie's also shut down. Of course, all the O'Charlie's across the nation did. I don't know. So the curse continues. I don't know if they open back up or not, but we're not going to meet at O'Charlie's after today's meeting. However, O'Calvin's is open. We're opening up our own franchise. So if you're interested in hanging out after today's meetup, go ahead and just raise your hand there in the chat. If there's enough interest, Calvin's going to open up that meetup, and we'll hang out with him. We did a little bit of this before the stream today. You're going to have to prepare your own appetizers and drinks, though, but you can certainly come out and hang out for networking, and just, we'll try to the closest we can to O'Charlie's. If you're interested in helping with Run CONDG, you can be part of the team. Just contact one of us, or throw it in the chat there. We're always looking for people who are interested in helping out and making CONDG better. So this is the group of leaders we have going on right now. So a few of these people are in the chat. So myself, I haven't seen Alan Barber yet or Adam yet, but Calvin is here, coding with Calvin TV. I haven't seen Kat yet, but Matt Eland. I hope I said it right this time. I probably didn't, but Integer Man is also in the chat. So if you want to, just contact one of us, and we'll get you involved. Yeah, hopefully O'Calvin's isn't cursed. And if you're new to Twitch, that's totally fine. If you have a Twitch account, you can log in and start joining into the chat there. So this is a little screenshot of how it might work from a web browser. It's a little different on mobile, but kind of the same idea. And I'm going to monitor, I've talked to Sean about this already, I'm going to monitor the chat for questions. And basically, I'll try to do my best to screen questions, but Sean's given me permission to interrupt him at any time to ask questions. So feel free to ask questions there. And as I mentioned before, if you don't want to create a Twitch account, that's totally fine. You can go to the meetup page instead and leave a comment there. I will also be monitoring that for questions. Okay, I think that's it. So at this time, I'm going to close down the slides, and I'm going to bring Sean over here. So Sean, you are now on. Can we get a little sound check from you, please?
Testing, 1, 2, testing.
Does that sound okay to everybody, or do I need to turn it up?
I'm a loudmouth, I can go up.
It looks a little quiet. Let me see if I can up that volume a little more. Okay, try it again.
I can go a lot higher too.
How's that? Does that sound better, everybody? Give us a little quick brown
Test.
fox.
A quick brown fox ran through the woods. Testing 1, 2. We're going to talk about microservices today.
Okay, I've got it all the way up now, so
Uh-oh.
might want to just turn up the volume on your speakers. It's up to
All right.
11. Um,
We're going to 11.
whoa! Now Sean's getting loud. Okay,
Uh-oh. Yeah. All right.
yeah,
Should go back down.
it's not hitting the red. I can tell from slobs here, so I think we're fine.
Okay.
And I can hear him, but I'm having a laptop on full. Okay, everyone's saying it's better.
All right.
It's fine. So
Good.
I'm gonna go away now, and I'm gonna hand it
All
over to
right.
Sean. Thank you very much, Sean. And where's the button for me to go away? Here it is. Boop.
All right. Thank you, everyone, for being here tonight. I really appreciate the invite to come and speak and talk about microservices. And this is something I've been working on for the last couple of years intimately, as well as doing some Azure architecture work, as well as for the last next month, it'll be 11 years that I've been running the Tulsa.NET user group. And we have also gone virtual since the pandemic hit, starting back in March. Thankfully, we already had a remote speaker set up, so we were just able to set up a WebEx and just run with it, go from there. So, and we actually meet twice a month right now, which is both good and bad. I've got a lot of speakers, but trying to keep attendance has been a good challenge for us. So, but anyway, tonight we are going to talk about microservices architecture, and the real goal of this talk is to kind of explain that it takes a lot more consideration than you might expect jumping in. And we're going to talk a lot about different aspects and nuances of the architecture. And we will go through this agenda. What are microservices? Why should you use them? And when should you not? Some challenges for the developers, as well as we're going to talk a little bit about decomposition coming from a monolith to a microservices architecture. And I'm going to keep it high level because we could do a workshop on that and it would still take a week. It's very involved. So, and with that decomposition, we'll talk a little bit about domain driven design. So, some really neat stuff, but I got to keep it high level for that. Okay, so what are microservices? Now, I've given this talk at conferences, and it's really nice to take just a quick second and ask people in the audience, what is your definition of a microservice? And I'll wait for a couple of hands to come up and kind of get some feedback on definitions. The problem is that there is not one solid universal definition. Everybody that is doing anything with microservices tends to have their own definition. So instead of actually providing a definition, I'm going to instead present some of the kind of attributes, if you will. And the key one, that since the microservices architecture is first and foremost, it's an architecture, the microservices are and should be treated as independent applications. And that is a big key thing, and so much that I will repeat that many times throughout this talk. Independent applications. And unlike having a method in a class and you're just going to do another, create an instance, you're going to call that method and it just jumps over to memory and calls that functionality. Now we're having to communicate over a network. Microservices do communicate over a network because they are intended to be distributed, not necessarily in memory, because it for the microservices to be true microservices, they are allowed to be hosted on various other computers, other servers. As well, a microservice, and this is one of the key things, they have a single responsibility. That does not mean one class, it does not mean one method, it means one responsibility. If this microservice, it does invoice management, then that's all it does. It doesn't also handle business functionality for human resources type things. Doesn't need to worry about medical benefits management. You take a domain, a business realm, if you would, and it's the Microservice has a single responsibility that serves that purpose. Don't put too many things all in one basket. As well, we're going to talk a little bit more about this a little bit later, that how they're owned by one team. We'll discuss what that really means. And individually deployable. And we'll talk a little bit more on that in just a moment too, about service autonomy. And again, this is microservices more about an architectural style than it is about code. We've got to start with a design and before we get to the code. So this is not a design pattern. This is a little higher level up. Yes, sir. Well, that's a good question. And I hate to give the consultant answer, but it's not me that's going to tell you where to draw that boundary of what the responsibility is. It's more for you and your team that is coding and managing that microservice. And what you may find is that you have a microservice and it's doing invoice management, and then maybe later through you're like, this the microservice is actually serving too much. It's got too much business logic in it, and you might actually have to separate things out. That really just depends on the business and how much of that business is actually part of that domain. Meaning, uh, I may say HR type functionality is very small unless you're a software development company and that's all you do is create software for HR, for human resources, for managing employees, benefits, etc. But even inside HR, you may still pull that out so that medical handling, be it medical benefits to short-term disability, things like that, are completely separate from vacation benefits or whatever else is thrown into that company's realm of HR and all the functionality. Even those might even be split apart. So I mentioned invoice management as a very quick example, but it's going to be you guys that help determine what all is really in there. And you mentioned the single responsibility principle. The single responsibility principle is about code level, where it kind of applies here in microservices, but it's moreover about don't have the microservice do too much. And throughout this talk, you'll see how that's kind of better explained in some examples of it as we go through. So hopefully that answered that question. Okay, so a monolith. The first thing about a monolith is that it's kind of all inclusive. Yeah, it might have some DLLs in it, but it's going to have its EXE, right? And it's got all the business functionality all in one giant assembly. There's no services that are called outside of itself unless it's maybe a third party thing, um, like sending something off to for getting paychecks created, things like that. The thing about a monolith though is by itself there's nothing wrong with them, and if you actually have a solid monolith, don't go to microservices. We'll talk a little bit more about that in a minute, but just because it's a monolith does not mean it's bad. What makes a monolith bad is when it has grown year after year, feature after feature, bug after patched bug, and we've all been there where you fix that one bug only to have five more, and then you end up with that spaghetti code. That's when that monolith becomes a big problem. So a lot of what happens with microservices is they will either are for the purpose of extracting existing functionality out of an existing monolith or have a new microservice with new business functionality. And you'll also see that a rarely will you have a total migration, meaning that all of the services in a monolith will be split out into their own microservices. That's rarely done. And we'll talk a little bit more about that in just a moment. There have been some companies that have succeeded doing it, but they certainly paid the price to get that done. And since I mentioned that microservices is an architecture, it is an implementation of distributed computing, where the idea here is that there's, five microservices there, and there's multiple instances of each one. And you can have microservices that will call my other microservices, just depends on how you need to split out that business functionality. But it also doesn't have to be a single layer, where it's not meant to be between the UI layer and the database layer. It's not meant for that. This is entirely different type of architecture. But it also allows the distribution of the problems, meaning that if I need a microservice to do this one thing and it does that really well, that single responsibility, but it can leverage another microservice where it has that service, those business functionalities separate so that they can be leveraged even if they're in different programming languages. That's one of the big aspects about microservices, and that we'll dig into. So why should you use them? Now, this is going to be my humble but correct opinion on the number one reason why you should use microservices at all is when you have that monolith and it is a big ball of mud, it's actually a coined term, that spaghetti code. And when the business is needing a new feature to be developed and out the door as quickly as possible, because it could mean revenue for the company, time to market. And when that has a giant impact for the company, then you come back and go, yeah, well, it's going to take at least 6 months or, well, 9 months now. Well, maybe I know, well, now we're 5 months into it, but I can tell you we're going to need another 6 months. Then that big ball of mud is so unmanageable that you're hurting your company's time to market on new features that can actually bring in revenue. So when a new functionality needs to be brought in and still leveraged by the monolith existing functionality, so that you need to be able to have that quicker time to market, and so that you're not jumping into that spaghetti code and making these little fine-tuned tweaks, so you can have separate code off to the side so that's a little bit safer to run. It also provides stability. We'll touch on that in just a moment about how you deploy with microservices. So, four tenets of microservices. We'll start with team autonomy. Like I alluded to earlier, microservices allows you to have multiple programming languages depending on what works best. I worked in one shop where the all of the backend development was done in C sharp, but they were also doing data analytics. And it was actually the data analytics processing that was in the microservices, but that was done in Python because Python is just a better language for doing some of that data analytics than C sharp. Not that C sharp can't do it, but Python lends really well. So certainly when you want to leverage the data analytics people on that team and they are Python developers, you're going to leverage what works best. It just means that you can use different languages when it makes sense to do so. Because you have, again, you're just calling across the network from a caller to a microservice. So you're going to end up with common protocols such as HTTP, for example, where programming languages don't come into the picture there. It also allows for the team to be focused on what exactly are they developing, so that comes back to that single responsibility, right? That we're only working with invoice management. So that microservice has a very specific domain of functionality that's going to be in there. So it helps to focus the team on exactly what that is for and why. And if you're already in an agile development environment, that works really well with microservices. Service autonomy. Back to that single responsibility. This is where you may have a monolith calling a microservice. You may have a microservice calling another microservice. To have a single responsibility is so that you are, just like I alluded to earlier, your business domain narrowed down to what is all that you need, is not too far spread and not including everything in one microservice. Now you might have multiple instances of microservices. That's a little different, but a microservice for maybe it is all of everything to do with medical benefits. Another microservice to deal with other parts of HR. Another microservice that deals with inventory management, pick tickets and when products are brought into the place versus when they go out. As well, it means that the services are deployable without other services. How many times have you tried to deploy that monolith and you've got multiple teams working on that monolith? That means multiple projects, multiple deadlines, multiple requirements. And okay, we're getting ready to go and deploy this. And oh, wait, sorry, this other team, they're not ready yet. Or they've brought in a change that hurts somebody else. With microservices architecture, it allows that development and that deployment of that microservice to be deployed and ran individually and independently. This is coming back to that, treated as an independent application. It's called by others, but shouldn't have dependencies on others. Now, you may think, yeah, but what if we deploy this new feature to this company and it requires functionality spread across multiple services? When you're deploying a feature, that's one thing. But when you're deploying services that are relying on other services and they're tied together, they're tightly coupled with dependent code, that those dependency packages, if you got custom NuGet packages or changes to a database schema, things like that, then you're becoming coupled and services dependent on others. And you will actually find yourself a little slower in the ability to deploy. Scalability. The idea here is that you can scale instances of microservices independent of the instances of other microservices. You might have in this picture, you might have one microservice and you may have four instances of it. Another microservice, you may have three instances of it, or maybe just one instance of a monolith. It all depends on what your needs are, right? I mean, no, I wouldn't recommend in a production environment that you're only running one instance of a monolith, but it's just there to get the point. The other thing about scalability with microservices is that with these instances of the microservices, it allows you to have the choice of choosing different servers, different size servers. Are you using virtual machines? If so, what size are they? How many do you have? It allows you the options of making the best choices and even changing that choice. If you're using Azure and you go through a VM, you're out in production, you realize that you're not getting the CPU usage. Maybe you have too much CPU. You can downscale, or maybe you don't have enough instances running, so you can scale up. It allows you that opportunity to scale up, scale out, and not affect other services. Fault isolation. The idea here is that you're going to have microservice A reliant on microservice B, reliant on microservice C, and maybe C has a bug in it. Should the bug keep the other microservices D and E from functioning properly? Imagine this scenario where you're looking on Amazon and you found a product, you're looking at this product and you're deciding if you should buy this product. You're looking at its description, you're looking at the ratings, you're looking at the other suggested products. Those are chances are, and I don't know 100% true of this, but I highly suspect that each little piece is served by a microservice, as in they have a rating microservice, a part description or item description microservice, and another microservice for looking at suggested products, as well as go get the reviews. If there was a bug in the rating microservice, should that stop the person from actually putting it in their cart and buying it? Of course not. And what if it's vice versa? What if there's a problem in the payment system? Should that stop the person from even be able to another customer from finding and searching for something to put into their cart? No, of course not. It allows related business functionality that are one service calling another to be independent of other microservices that have nothing to do with that process. So it actually provides some of that fault isolation. And I saw this in a commercial and I thought that line was funny, stay in your lane, bro. So I added that in there. It's kind of a way of remembering that, just stay in your lane. If you have problems, you stay over there. We can continue working over here. And I mentioned earlier that it's rare to have a total migration to a microservices architecture where everything is a microservice. But these three companies have done it. Netflix, eBay, and Amazon have done that, but they have also, like I said, paid the price. They would build things out, learning how to do it. They spent a lot of money. They would stop, reorganize, re engineer, and put a lot of time and effort into building out those microservices and doing a total migration. It's rare, but it can be done. Just have to decide if you really want to put forth the time and effort and a lot of money to do that. So, why should you not use microservices? Well, kind of the not really meant to be a cop out, but they're hard. They really are because you're gonna try things, you're gonna fail, you're gonna rework things. You're gonna have to experiment a lot to see, is this the right, are we doing it the right way? Did we put too much code in one service? Not enough. Do we still need to migrate things over? Are we scaled enough? There's a lot to go in to doing them right. But as I mentioned, even doing good programming is hard to do as well. So, there's some guidelines as to when you should not use microservices. If your monolith is just too small, it might actually be easier and cheaper and less headache on you if you just make multiple instances of your monolith and even using feature flags so that these instances over here are for this processing, where the instances over here are for this processing. It's the same code base spread across multiple servers, and they're flagged for what are they actually going to work on. I have seen that before, and it's not necessarily a bad decision. Certainly, if it means it'll help provide time and um, allow for effort to be put in there to see is if going to microservices is truly the right decision. And if it buys you some time while you're working out the headaches on something else, there's really nothing wrong with that. And if your microservice has too much coupling, too much code dependencies, and you're not using like things like AutoFac, for example, um, you might need to do a lot of refactoring first to put yourself in a position so that you can draw a line around a boundary and say, okay, this is the functionality we're going to pull over to a microservice. And if your development team is not willing or not ready, you're going to have a lot of friction and a lot of bumps along the way. You're going to need to have everybody on board so that it is on board for training, to try things out, to reorganize, re-engineer, and just fight those battles. As well as, if you're the team that wrote it, you should also be the team that supports it. You know that business logic, and you know why why it works the way it does, and how you got to that process, that way of thinking for it. So you also need to be in a position to support that microservice. And like I mentioned, they're costly. It takes a lot of time and money. So let's look at some challenges to microservices. You might have also heard of these as fallacies. You may think that microservices are cheap. They're not. They take a lot of time and money to do them right, to do them well. Now, to do proof of concepts, no, go for it. Jump in, see how it works. That's part of that learning. And for us developers, we're not really used to doing networking type things. And now we're going to need to. We need to understand, should we do a direct HTTP call to a single IP address? Should we use RPC, that remote procedure call? Should we use a load balancer? How does it know about the instances of the microservices? What if should we not use RPC and maybe we ought to go with a messaging based system? So more of asynchronous. We'll do a publication subscription type thing, pub sub. What about sagas and routing slips? There's a lot of other decisions that need to be made. And back to this one, you may think of it as just copy files over to a server. Well, in reality, microservices, because they are independent applications, they need to have their own CI/CD pipeline per microservice, continuous integration, continuous deployment pipeline per microservice. Why? Because they're independent applications. Treat them as such, love them as such, develop them as such, and you'll see how the only thing that connects them is the how they're leveraged. And because they are a independent application, they also need to have their own code repository to themselves. And it helps keep away from dependencies. And I mentioned this too, is like as developers, we didn't have to worry about networking before. Well, now we do need to worry about networking. We need to understand what the OSI model is. And you may not have to rattle it off top of your head, but you do need to understand layer 4 and layer 7. And security. This is an interesting one because you may say, well, we're behind a firewall, we have an internal network. Do we really need to secure the traffic that's inside, maybe from the monolith to a microservice? Well, the idea here is, what if you brought in somebody else's code? You're leveraging a NuGet package or some other code package, and you haven't looked at their source code. How do you know it's not sniffing the network? How do you know it's not looking for other things? By using TLS, even between microservices, the monolith to microservice or microservice to other microservices, you want to encrypt that data. And you get into things like Kubernetes, you're going to want to look at a service mesh like Istio that can help provide that security, that encryption of data between calls. And just because you wrote the microservice that deals with, say, maybe an employee's paycheck, should anybody's code be able to call it? Or should it be restricted so that only authorized callers are allowed to call that microservice and leverage its abilities? So then you get into something like, for example, OAuth, so that there is a security layer to provide who are you and are you really supposed to be able to call this microservice? And I mentioned common code because sharing code between services causes tightly coupled services. Then you have, say, you've got service. Well, we'll talk on this in just a moment, but you've got multiple microservices and they're dependent on common code. You may end up in a position where challenging requirements and challenging deadlines hurt another service that is not meant to be related to that. So a brief touch on the OSI model. When we look at layer 3 and 4, this is where TCP/IP and IP TCP and UDP come in, as well as IP and ICMP for ping. But the reason you need to understand about layer 4 is because that's what most of the load balancers use. Because you may have multiple instances of a microservice, but your monolith should not have to worry about knowing the number of instances and where they're all located. If it's set up to call one load balancer, so it has to only know about one address, and let it worry about the number of other instances going on. So now you're dealing with layer 4. But why layer 7? HTTP. I'm sure a lot of you are already familiar with model view controller. Well, of course, what's the one letter that they leave off there that's still involved in this? What's routing? And that routing is at the application layer. As the requests come in, it gets routed to the controller that's going to handle that request. So the same thing with dealing with RPC type based calls, where you're going to do a direct HTTP call to a microservice. You need to understand how it comes in at layer 7. Code dependencies. This is that scenario I was mentioning where you have service A, microservice A, and microservice B, and they're owned by individual teams, but they're also reliant on a common code because they firmly believe in DRY, do not repeat yourself. So they have all of that common code into their custom NuGet package so they don't have to rewrite, don't have duplicate data or duplicate code, right? So Team A has made their changes to that NuGet package so that they can get their next version out. But Team B with their microservice now has a breaking change because what worked for Team A is now hurting Team B's service. Well, the problem is, what are you going to do with this? This is where you don't want to have common code, but that goes against the DRY principle. Don't repeat yourself. Here's the suggestion. Instead of having one custom NuGet package shared between them all, split out what should be split out, even if that means duplicate code. Why should you duplicate code? Because if you have a custom NuGet package for service A, it's going to have an evolve based on the context and purposes of this service. But what about the dependencies of the code for service B? Yeah, well, it's duplicated code. Maybe, but not for long, because there will have, where it is duplicated, it'll evolve separately into its own context. And this rule actually applies, this guidance actually applies when you get into domain-driven design, when you talk about bounded contexts. We'll talk a little about that in just a moment. So the advice here is separate the code that changes to their own package for the services that need them. Let what was common code where they need to split, go out to their individual microservices so they can evolve separately. You break what was a tight coupling. But a quick question. When you look at that common NuGet package there in the middle, which team owns it? There's another problem, right? You'd have to have teams of developers that manage this stuff and own the code and the responsibility thereof. Who owns that common? You may think, well, everybody does. That brings up challenging deadlines and challenging requirements. Got to be very careful with that. All right, so now you've decided we're going to go ahead and we're going to build our first microservice. So you start moving over functionality out of the monolith. And then you realize, well, this service is actually dependent on other code and that functionality. Okay, well, then it becomes dependent on something else. So we got to bring it over to that microservice. And you end up with not another microservice, you end up with another monolith. This is a bad position to be in, unless it's a bad position to be in if this is your final step. However, if you've done some period of time of development and you've gotten yourself into this position, but you're able to go to production with it and you have bought yourself more time, and this becomes not a final spot, but a stepping stone to finer grained services to where they are true microservices, then that's fine. This is simply a step on the way. This is part of that learning where some people get here and hopefully not stop here and live with this. Maybe they retract, maybe they cut their losses and go back to what they were doing earlier. This is where that time and money come in, and having the ability to try things out and fail if need be. You have to jump in and try it. You're going to have to discover where the services lie, the service boundaries, that you can cleanly cut that functionality over and its dependencies over to another microservice where it truly belongs. You may do a lot of refactoring. You will be worth it in the end, but it's going to take a lot of effort. So then we get into this problem. We just talked about separating code from dependency. Then there's other rule that is in many, many books about microservices is you need to decentralize your data, meaning that every microservice actually needs to have their own database. Well, I did not like that answer when I was first learning about microservices, and I thought, well, I've grown up with SQL Server and a nice relational database that's full of records, and no, you don't want to do a microservice and pull that data out. Well, I've come to learn otherwise, and this is what I'm going to share with you. When a microservice does need to persist data, then it should own that data. It should be the single source of truth for the data that it owns. And here's what we're going to do to get into that. So we have our monolith there on the left, and it's dependent on that relational database, just for an example. And then we create an orders microservice and a parts microservice. And not to leave things too far alone, we decide we're going to go ahead and make a shipping microservice as well. Well, what should the parts microservice own? Well, shipping is dependent on orders, and orders is depending on parts, but you're saying we need to split that out and don't have it centralized. Let's go through this process and you'll see. So what's in the parts database? The parts microservice is considered the single source of truth for this data. And you might have something like this where you have, oh, I missed something, didn't I? Yes. Okay. I gotta have this because it's just part of this. Imagine a database, a centralized database that has all of these tables in this database, single database for accounts, your customers, your orders, orders history, your parts one, shipping history, and logging. Yeah, I said parts one because as the parts table evolves, and as it usually does, you'll end up with yet another parts table to handle the changes because what was fine 5 years ago is no longer fine. We had to adapt and make changes. So, and since naming is hard, we make parts one table, proving that schema changes are a problem. So then we get into our microservices, as I was mentioning, and our parts microservice becomes our single source of truth. And you might have columns in that database for ID, natural key, and part number, etc. And but also includes things like the manufacturer of that part. What was the manufacturer's part number? When was it manufactured? Does it replace another part number? Or has it been discontinued? Well, when you look at the orders microservice that is dependent on parts, what does it need to know about a part for an order? See, an order for a part doesn't really need the manufacturing information. So in this case, it makes sense to duplicate data. I know what you're thinking. How dare we? Can't do that. This is actually a benefit. The parts microservice becomes the single source of truth of everything about that part. But when you duplicate just enough data for another microservice to be able to operate independent, then you're allowing for a separation to occur where it needs to. And just like we was talking about with code, you want to separate the things that need to evolve independently. It's the same thing here. The key thing being, it's when the schema changes. when you have a service over here that's challenging, it needs to make changes to the database schema, and it challenges the needs of another microservice or service, then you have a challenge of schema where here, by them being individual, and yes, it may be copies of data, it allows them to evolve individually. And that's the key thing. That's the key reason for decentralizing data. Allow even schema changes to evolve independently. So then the next question comes up. Well, how do you keep the data in sync? Well, if we've got all these microservices and you're telling me to copy some of the data, how is it that things are supposed to be kept in sync? Well, does it make sense that the orders microservice calls the parts microservice for that information instead of storing it? It could. And depending on the size of your data, it might be just fine. But you may also notice that because it's going across a network, therefore you already have a little bit of inherent latency, that when a microservice is calling another microservice to get data that it could have actually be storing, it's a very chatty network. And you end up with other latencies that you don't need to have. So how do we keep them in sync then if we don't want our microservice calling another microservice? What if we change the architecture? What if we went into something like where our monolith and other microservices can issue messages on a message bus? And what happens then is, as a part of information about a part, let's say a typo happened and the part description or the part name was updated, then a message can be sent. And then the microservices that are going to listen in and care about that type of message called a topic, they can key on that, grab that message, and they individually handle the changes as they need to. And this allows for data to be kept in sync without a microservice dependent on another microservice. It allows our parts database to be the single source of truth, while our inventory system and our order system and our maybe our UI, our web layer, um, they're aware of the changes, but they're not tightly coupled to the microservices. Now, I mentioned a saga here, and with a saga type of messaging, it allows for the microservices to react based on that message, but even if that's an undo type of process. So imagine a order comes in, and so from the UI, let's pretend it's being handled by the monolith, and it lets the order microservice say, "I need you to generate a new order." Uh, so there's a message created and sent, and then the parts database picks up on that, and shipping is aware of it, and that way it keeps them in sync until. But with a saga, it allows for things to go wrong and be able to backtrace on their changes. Yes,
Question for you, Sean. So each service needs to be responsible for monitoring for messages to update data sent to the bus?
yes, yes. So they are, if you think of it as a publish subscribe, and you think of it as like a chat room. You're on Twitch, you're on Discord. You get to decide of all the messaging going around, what do you want to pay attention to? What should get your what should notify you? What should get your attention? And although they don't have to listen to every message, they can, and you, the developers, are going to say and decide what messages will it be sent and what messages will receive and be reacting to. I hope that helps answer the question. So yes, if you're going to use messaging, it could be several messages, several message types, but also for something like a new order or a typo fixed, those are tiny messages. And it also it allows for the system to not be synchronous, meaning that let's say it was the UI where an admin fixed the typo, and then they said, "Okay, go." Well, you know, an RPC type of call, they're kind of having to wait for that call to go out and go, "Okay, yes, we're good. It updated, and we're back." With a messaging system, it says, "Oh, we got a typo fixed. Great, let's go on." Yes.
Another question, Sean. So to clarify, the main reason for duplicating parts in order is to avoid the network traffic of having to call parts. Is that correct?
It helps keep down the chatter of extra network calls, as well as it allows the order microservice to be in charge of what data it actually wants to store. And meaning that it doesn't need everything about a part. It may not, an order really doesn't need to know about manufacturing type of data about the part. Maybe just, 5 details, not 15. So it helps break that coupling at the schema.
Thank you. That makes sense. Another question coming in. What is
Yes.
the best strategy to sync duplicate data in different databases?
What is the best way to sync duplicated data in other databases?
Let
Did
me,
I did I
let me,
hear that
uh,
correctly?
let me repeat one more time. What
Yes.
is the best strategy to sync duplicate data in different databases?
Oh, okay. I would still lean towards the Saga because how do you know it's duplicated? Meaning, if a message comes in that says, we've added this new part. Well, we've already added this part. That actually comes down to a talk that a friend of mine gives called Acid 2.0 by Michael Perry, and dealing with distributed computing, distributed architecture. And that way it may pick up a message that says we need to insert this part, but it actually is already there. Your system needs to know, go, well, this is actually a duplicate message, or it was a message that was actually sent out of order. So each microservice will still need to handle those conditions. Are they item potent or commutative? So that's a great conversation for Michael's talk. But it does put the onus on each of the microservices that could receive data that could be duplicate to have the ability to go, wait, I've already received this message before. And there are tactics around how to determine that. It's outside the scope of this talk right now, but afterwards, hit me up and we'll talk about Michael Perry's talk. And I definitely want to get Michael Perry here for this user group because his talk on how to deal with those scenarios right there is mind blowing. It is a really good talk on how to handle that. So hopefully that answered that question, but I can get you some other details. All right, so let's look at another scenario. Me personally, I have multiple checking accounts, and one of which is an internet checking account, meaning that when I buy things off of Amazon or other places, they only know of one checking account. And that way, if it's ever hacked, well, they only got maybe 100 or $200 that I have in that account at that time. They don't have where my paycheck lands. They only have the amount of money that I put into that one account. So I move money over there and then I make my Amazon purchases and such. And well, I mean, it happens, sometimes you buy things and you forget where your balance is at. So I place another order on Amazon. And now, granted, in this case, they're entirely microservices. They don't have a monolith, but for our sake right here, we've got a monolith. And a purchase was made through the UI. And so an order was generated. And the payment microservice was told to go and process this payment for this customer. And the inventory microservice was notified. So, hey, get ready to go pull this item off the shelf and get packages and then get ready to ship it. And then the payment processor comes back and says, well, we got a problem. There was not sufficient funds. Yeah, well, I missed it by $1, something like that. And I forgot to move money over to that account. And so what Amazon does is, they've already sent you the email that says, thank you for your order. Then they'll notify you later. It says, wait a minute, there's a payment problem. Fix this, and we'd be happy to send it to you. The other thing about using a Saga is that allows the independent applications, those microservices, to independently act and react depending on the messages. So now with that Saga that's fully associated to that order creation and the payment processing and the inventory change, well, the payment system says, wait, we got a problem. I can't continue. There's a problem in this processing. So with that Saga allowing things to be tied together, it says, well, all right, we'll go notify the inventory system. Well, what does it do? It's going to get that message and it says, okay, well, we pulled it from the shelf. Now we're going to put it back on the shelf. Kind of an undo, right? Well, the order system also gets that message and it shouldn't delete the order because deleting data is bad. Another thing from Michael Perry. Instead, the order that was newly created, instead of being deleted, it says, wait, the payment failed. We're going to change the status of this order to maybe payment pending, something like that. Something to indicate that the order has been created, but it's not in a state or status that allows it to continue until something else has changed the payment. And as well, sagas can be used where if a microservice does actually fail to operate, maybe it hit a bug in the code. I know I don't write them either. I hear you. I don't write those bugs either. But we'll say pretend, okay? It's always somebody else that writes those bugs. I get it. I get it. But what if? Well, in that saga, that message is sent, and those independent applications, those microservices, can react based on those conditions. And that way, it helps you keep things in sync to where they need to be, even through a failure through messaging and you using by the use of a saga. It allows you to keep things in sync and flowing. All right, we're going to shift gears and we're going to go into decomposition. And like I mentioned earlier, we need to keep it high level because it is very, very involved talking about domain driven design. But I'm going to try to do my best to do what I can in just a few minutes here. So you saw this earlier where the purpose of a microservice is to extract data, functionality out from a monolith, or you have a new microservice that has new functionality. And as you've decided to do this, you take another look at your code and realize we don't have clear boundaries in our existing services. And we're really not using dependency injection like we should be. So we don't know where our boundaries are. You're going to go through a lot of refactoring first. You have to. Then you can get into a position where you will be able to piece off what you do need to move and discovering what you need to move is what we're going to get ready to talk about. So let me cover a quick question. How do you get started? And I've handled that question multiple times. The quick advice is start small. And the reason why is you start with a small, tiny piece of functionality. Maybe it's only 50 methods. And maybe that's just small functionality. I don't know. Depends because a microservice doesn't have to be one class, one method. That's way too micro. It's not what it's for. But when you take off a little tiny piece, you still have to build the infrastructure. You still have to build that code repo. You still have to build the deployment pipeline. And it doesn't matter the size of the code, you still have to put those things in place. You still have to get a team ready. You still have to get everybody up on the same, as much as you can, on the same page about microservices so that you can at least start off correctly. and in the right direction. So let's take an example here. Our company Wham Bam, well, they make fidget widgets, and their main domain is that they are a production company, meaning that they don't write software for HR. They don't write software for like Quicken Loans. Sorry, like Quicken Loans, for example, for financial things. They're a production company, so their main domain is the production, and they have other types of domains that are secondary to that, that are purchasing and shipping in this case. And then you have other things that are not core. They are uh, the generic domains, which means that they could easily be replaced off the shelf if need be. And so we're going to look at a production company and try to develop some software for them. Well, they have existing software, and we need to see if we need to make a microservice out of this. And you notice I mentioned event storming up there. Event storming is a way of understanding your existing code, and I highly suggest it. Get everybody in a room. You got your whiteboards, or what I've seen before is butcher paper, and you've got it across the halls or whatever. You've got different colored post-it notes, and you're going through what is a domain and what are domain events. And you get your domain experts. Those are those subject matter experts. They're not programmers. They're the ones doing the day-to-day job, and you're learning from them what the software is doing and what it should be doing. And it allows that the subject matter experts to not have to worry about programming speak, because they're not programmers. They're not doing our job. Instead, we're developing software for them. And since it needs to be for them to operate, we need to understand how they do their job. Event storming is a great way of understanding the business functionality. How do things talk? How do things work? How do things react when other things occur? So we've decided that we understanding our domain models, and we leveraged event storming, for example, and we're going to dig into the two domains, production and purchasing. And as you're looking at this code, you see that the production uh, uh, set of domain on the right, and then you got purchasing on the left. And you realize that the code and the functionality on the right, well, that actually, they actually operate together. Now, we're not talking about order creation. This is not necessarily an order uh, management, order in single source of truth for the orders. This is just code that helps understand about an order for the production of a product, our fidget widgets. And the same with parts and vendors. These are not microservices. This is just existing code so that we can operate and do things as they relate. And you find actually what's common, that the parts, order, and products, they go together. So we draw a circle around them. And then vendors and parts, well, they go together, and that's for purchasing. And then you notice something interesting is that, well, we have a class for parts for purchasing, but we also have that same parts class for production. Well, there's a coupling. We have a problem going on. Well, when you're talking on the board and not looking at code just yet, then you understand what a lot of the subject matter experts, your domain experts, are looking at and going, well, we don't call them parts. We call them produced or purchased parts, or assembled parts or assembly parts. And by doing that, by setting up and changing the language, instead of having a tightly coupled system, what you allow is what's called a ubiquitous language. So now even the developers are on the same page with subject matter experts on what they call the different pieces that they work with day in and day out. And it allows them to be different because they are different to the context that they belong in. And in this case, yes, we have two different bounded contexts, purchasing and production. And depending on who you hear this from, ubiquitous language is actually considered one of the biggest tenets of domain-driven design, is understanding the difference in the language. Even to be suggested that your namespaces, your class names, and method names be created and named so that they fit the ubiquitous language, not be generic. Don't have account. What type of an account is it? Name them so that anybody can come in, like you 6 months later, or somebody else on the team can look at it and go, I know exactly what he means. This is an assembly part, not a purchased part. So now we're going to dig in a little further. Now we're going to look at and pay a little closer attention to that order and products that's inside of the bounded context for production. And what we're bringing up here is what's called aggregates. This is the class level things. So now you have a class called order and a class called order line because the order is made up of order lines. And then you have a product that is dependent on another class called assembly parts. It's not parts, it's assembly parts because a product is made of parts. Let me go back and just kind of mention this a little bit. So I've got different parts here. Let me kind of better explain this. I used to work at a manufacturing company here in Tulsa, and they would buy raw material. That's that purchased parts. They would buy them from an upstream vendor, and those raw product would get brought into the shop. Maybe it's like giant rolls of aluminum, for example. Maybe it's just a lot uh, of nuts and bolts and things like that. It's already made, right? And so they brought them in. Well, for us to make a final product, there has to be a mid step in. So they take these raw parts and they put them together, and they have a part that they don't sell, but this part is actually something a part of a bigger product that they do sell. And that's where that assembly parts comes in. So when we're looking at here at code, we can see that our product is made of assembly parts, just like an order is made up of order lines. And there are two aggregates here, one for order, one for product. And the order and product are individual aggregate roots. And with Eric Evans, who created domain-driven design, has a rule that says a function inside of an aggregate can call another aggregate, but it must call the aggregate root. It must not call any place in the aggregate other than the root. The reason for that is imagine we have functionality dealing with order line and it decides to jump over and change details about an assembly part that the code and product doesn't know about. You actually risk damaging data integrity. So you think of them as front doors, the order and the product, where they have the functionality to affect things that are below them. If something needs to change something about an assembly part, then it has to go through the product. And if that functionality is not there, then it doesn't happen. Well, if it needs to be there, well, then you add that functionality at the root so that that can keep the data integrity of all the dependents down below. Okay, so we're going to go one more step further because we're still haven't at that microservice yet. So what we've decided to do, and again, we're going to talk about possible service. It all depends on your needs as you try to implement this. I cannot tell you that this is a 100% right way to do it. It really depends on your needs. But for this, we can pretend that we've decided we're going to create a production microservice so that we can work with and have a reign on the functionality that is exposed for our monolith or other microservices as need be. And maybe it has functionality for dealing with assembling parts and or assembling the products and inserting an order, not that it's the order single source of truth because that would be too many things in one microservice, right? Now we got two different domains that don't belong. This is not what this is meaning for. This is where it has enough information that the building of a product can get the job done. Why are we doing this product? Why are we building this product and to what specs? Well, it's based on this order. So then you may wrap a circle around that and say, okay, this might be a spot for a microservice. And here's the kind of functionality that we'll have. And as I mentioned, this has one bounded context. And it is possible that a microservice can have one or more bounded context. Now, the same rule applies. If you have multiple bounded contexts, how does one code over here in one side call code over here? By going through the aggregate root. And that way, even at the class level, you're protecting data integrity. So I mentioned that there's the rule that says a bounded context cannot be served, cannot serve multiple microservices. A microservice can have more than one bounded context, but you're not going to share a bounded context across microservices. Why? Because a microservice should be always considered and treated as an independent application. You notice I keep repeating that. Independent application. And if we were to allow a bounded context of business functionality to go across multiple microservices, you've actually created a tight coupling. Now, I say don't do that, but there is one case where you will. I know. For every don't ever do it, there's always one, okay, well, this time you will. In the scenario where a bounded context is shared, is not with business logic, but it's actually with cross-cutting concerns. Should every microservice have their different way of logging, their different way of monitoring? What if the entire development team and multiple teams have decided maybe we're using Log4net, for example, for our logging? Well, then you might bring this in and say, okay, well, we're going to use our logging code that's not about business functionality, but it's about cross-cutting concerns, and it's being leveraged across multiple microservices. Okay, we're actually at the end. So we're going to do a really quick review. Microservices are hard. So is good programming. It takes a lot of time. It takes a lot of money and a lot of chances to try things out and see what works. Find out, how do you know that it even works well? How do you know it's not working well? Are you using the right strategy for the calls? Should you use RPC? Should it be synchronous? Should it be asynchronous? Should you use a messaging type message bus? Should it be a pub sub? You need to create a CI/CD pipeline for every microservice because they are independent applications. Create a code repository for each microservice because they are independent application. And be careful of sharing code because it provides tight coupling. Get to know a little bit more about the OSI model, understand about networking. I haven't even talked on about more details about load balancers and network security groups and networks and subnets and how do you govern access at all and things. There's so much more that needs to be learned and understood about that. And don't just think that it's somebody else's job. With microservices being called across a network, it's your job too. You also understand about encryption, the need for encrypting that data in that payload so that it cannot just be sniffed by somebody else's random rogue code, for example. And if you do have sensitive data being held in a microservice, managed in a microservice, not everybody should be calling that microservice. So you're going to want to be able to have a gatekeeper on there. Team autonomy. One team owns that microservice. Don't have a microservice owned by multiple teams, else you end up having challenges of requirements and deadlines. And people not coming together on the right way to do things or the one way to do things. Service autonomy, so that you're not dependent on one microservice on another. Allows it to be individually deployed so that you can get a new feature, a bug fix, or something else out. Now, if it's a new feature and that has to go hand in hand, well, that makes sense, but it's coupled, but not tight coupling. Scalability, allowing for your choice of uh, wh- uh, what servers do you want to use? How many instances of a microservice do you use? Where are you going to put your servers? Are they going to be in multiple networks? Are they in multiple data centers? How are they going to be called? What's your latency that you have to deal with? And it allows for fault isolation. So if something does go wrong, you have that, you can build in that separation so that it doesn't affect other microservices and the business functionality that occurs there. We also talked a little bit, and I mentioned it's very, very high level. There's so much more to go with domain driven design. And we could be here for hours and still not done talking about domain driven design. But understand about a bounded context. That's an existing set of code that belong together, classes that belong together, and they're not tightly coupled to things in another bounded context. Because if you do have something that's tightly coupled between two bounded contexts and you have to split them, duplicate the code so that what is duplicated can evolve independently of its duplicate in another bounded context. You may have an account or a user, but they may be context specific and they will behave differently. It's okay to duplicate that code to the context they belong in. And we also touched on aggregates, where you have this is that class level thing. So you see your dependencies, and we talked a little bit about aggregate roots and how an aggregate can call over to another aggregate as long as it's going through the root first, else you risk challenging domain data integrity. Some recommendations I have. I highly suggest Microservices Patterns by Chris Richardson. This is a fantastic book, and he's got a website out, I believe it's microservices.io, that has just a ton of great information out there. Eric Evans, who created Domain Driven Design, his book there. And if you do read that book, as I believe it's section 4, you'll start with that one first. He has already said that if he had to rewrite the book, it would be different in different order. So the other one is Patterns, Principles, and Practices of Domain Driven Design, PPP of DDD, by Scott Millett and Nick Toon. I highly suggest that book as well, because I've read Domain Driven Design by Eric Evans, but the way that it was presented, um, just like you might know of microservices already, but maybe caught a piece of this talk that was explained something just from a different angle. So does that book about domain driven design, and it's very helpful. And with that, here's some details about me. There's some other Twitch friends I highly suggest. Of course, check out Matthew Groves on his Twitch channel, and Kevin Allen. And I'm friends with Developers Garage. Is Ryan Overton. He's also here out of Tulsa, and Tell Learn Code, which is not too far from you guys. He's over in Louisville, Kentucky, and I've been president at the .NET User Group for the last 11 years now, and I'm a cloud architect at TokenX. We deal with securing and encrypting credit card information. And you can find us on the meetup right there, Tulsa Developers-Net. And with that, Mr. Matthew, are there any other questions?
Hey, Sean, I don't think there's any questions just yet, but if you think of one, go ahead and drop them right there in the chat. Let me just turn some things back on here. Hey, there I am. All right. So thank you very much, sir. Yeah, we got some Inception going. Absolutely. Bug on my screen too. Okay. Round of applause for Sean, everybody. We don't have a applause. We can't have microphones in everybody's house, but everybody throw up your favorite emoji, emote there in the chat.
There you go.
And we'll consider that applause.
I actually do really appreciate feedback, even negative feedback, so that I treat that as constructive so that I can tweak this and make it better. In fact, I tweaked some of the slides today just so I can tweak and make this better and be more explanatory. So I really appreciate the feedback.
Terrific. Okay, so
Vulcan salute. I
yes,
like
Vulcan
that.
salute. All right. Now, I do want to just say before I go on with stuff, if you're interested in going to O'Calvin's, this is your last chance to throw something up in the chat there that you want to do that. I think there's a few people who are interested in following up on some questions. Sean, I don't. If you're interested in
Yes.
going to Al Calvin's, I don't want to put you on the spot, but if you're interested in that, that's going to be on a Google Meet.
Okay.
Integer Man says he's up for O'Calvin's, so if anyone else wants to do that, I'll let that let Calvin decide how he wants to handle the logistics of that. You can post a link in here if you want to, or you can whisper to
Okay.
people, whatever you want to do, Calvin. I am, it's O'Calvin's, it's not O Matthews. I do want to say one more time, if you're interested in entering the prize, entering the raffle, please put a chat message in there right now. There may be a bug in my chat bot. It's not picking up everybody. I think I might know what the bug is. So make sure to just throw another message in the chat just to make sure you are included. You don't have to say anything incredibly detailed. You can just throw ASDF in there if you want to. Just to make sure that you're covered. I want to say thank you for the follows during the presentation. Usually there's more fanfare on Twitch here for follows, but I want to say thank you to Smashing Provin, Wes O, and CSP Mosh for the follows. And thank you, Source for the raid. I think Source might have raided us last time as well, so very cool to see that. Thank you very much. Okay, and you must be present to win. You might want to put your full-size camera back on there, Sean. I'm going to change your window up a little bit. Okay, there we go. You must be present to win these prizes. And for the physical prizes, I'm going to give out the robot and the notebook. Please, those are going to be limited to the United States only, just because I'm going to be mailing them out. I don't want to have to deal with the international postage, especially during these challenging times.
I've got a quick story on that because I just did that two of my meetings ago. And I said, I'm going to go ahead and mail this book. It's on software architecture. It's not the lightest book, but I'm going to personally mail this to somebody. But I do appreciate if you're in the 48 continental states, right? And I did have some members that were joining from other countries, and it's like, I'm sorry, but I got to keep it continental just for cost. It's out of my pocket. I just want to do this. And this guy won, and he has a Russian name. And I said, okay, I'm glad you won. But I got to ask, are you at least in the 48 continental states? He goes, oh, yes, absolutely. Turns out he's in a neighboring town of Tulsa. Okay, great. This is great. It's
easy.
Great to mail it to him. It's great. So.
Okay. All right. So now's a chance to get those chat messages in. Again, even if you put one in already, just do it again just to make sure. It doesn't have to be anything super important. All right. So let me bring over my little SQL query tool here. Oh, that's the wrong one. Sorry. This is the one I want right here. Every message goes into a Couchbase server running on Azure right now, and I've got the SQL query here to pick everybody within a certain date range up till now, order them randomly, and limit them to just one. Of course, the SQL query. What else would I do on the stream besides write SQL queries?
And Couchbase it's relational, right?
No, Couchbase is a NoSQL database.
Ah, that's awesome.
Yes, okay. I agree. It is very awesome.
Yeah.
Okay, so
go ahead. I'm sorry.
No, that's okay. We can talk about Couchbase all day, but I think people are probably sick of hearing me talk about it. All right, so third place prize, speaking of Couchbase, is this amazing Couchbase notebook. Find blank pages inside for you to write your notes on it. Also comes with this nice little pen that can also act as a stylus. Very cool. And I'm going to throw in some a Couchbase pin. And these aren't all of them, but Couchbase sticker pack as well. Oh, it's green screening some of them. That's pretty cool. But you get all those. That's the third place prize. Bobcat's making some noises there. I don't know what that means. But okay, the winner of the third place prize is, drumroll please, Sam R. Bilbrey. Sam R. Bilbrey, are you around? You got to be present to win. So let me know that you're there. If you are there, just say you're in the chat, and then you can email me. I'm me@mgroves.com, or you can just whisper to me on Twitch. So here's my email address. You can email me there. Sam R. Bilbrey. There you are. Okay, so I'm gonna make a note here. Sam R. Bilbrey gets the 3rd place prize. So you can email me there, or again, you can whisper on Twitch, whatever you want to do, whatever you're comfortable with. All right, that's 3rd place. 2nd place. What was 2nd place? Yeah, 2nd place was this robot. This is an AT robot, like a little smart robot. It can respond to voice commands. It can do recordings, touch control. He moves around. He's super cute. He can dance, sing, talk. It's fun stuff. 2nd place prize, and they also throw in a Couchbase pin and sticker pack with this as well.
Wow,
So
that is a really cool robot.
yeah, it's pretty cool. This is the 2nd place prize. He dance and sings too. Domo arigato, Mr. Roboto. Yes. Okay, that's me. All right, 2nd place prize, drum roll please, is Source Scoots. Source Scoot with the raid and the prize. Are you in the United States, Source Scoot? If you are, and if you're still there, just say hello. You probably raided and left because you're exhausted after your stream. So if you're not there, I totally understand. Yeah, and you're in Europe anyway, so probably can't send this to you. Sorry. We'll do something for you, Source Scoot. I'm sure. Okay. So you're still in the drawing for the JetBrains license. All right. So we'll do another winner here. This is again for the robot. Drum roll, please. Integer Man. Integer Man. Do you consider yourself eligible? He's one of the leaders of the group. This is totally fair drawing. So if you want an Integer Man, I'll send you this robot. He waves, okay? Next winner, drum roll, please. AJ 2017. AJ 2017. I know you're here, AJ. I just saw you. You want this robot? Say you're here, and it will be yours. I will send it your way. You're here. All right. So AJ 2017. I didn't send you one of these already, did I? Did you win a prize? No, you wanted a prize on my other streams. Okay. 2nd prize, AJ. So just send me your... I think I have your email already. But send it to me anyway. Send me your shipping information. I will get that out to you. Okay, 1st place prize. I don't have a physical thing, but let me bring up something on the screen to represent it here. This will be a license from JetBrains for any one of their products, certainly for the .NET group, ReSharper. I'm covering up Sean here, sorry. There you go. You'll be interested in ReSharper or Project Writer, but there's lots of other great stuff they make. TeamCity and PHP Storm and lots of good stuff for Ruby and things like that. So a license for you. This is our grand prize. So I don't think you need to be in the States to win this one. It's just going to be a PDF file that I send you. All right, so drum roll, please. Code with Sean. Code with Sean. Are you around? Code with Sean.
That's the guy that presented.
Oh, that's you. Oh,
yes.
Okay. Never mind. Sorry. I thought it was a different Sean for some reason. Okay.
I'll take the robot, though.
Okay. We'll do another one. Drum roll and Wes O. Wes O. Who's a new follower, by the way. Thank you, Wes O. Are you still around? Say something in the chat. Hello, Wes O. Sean won the 1st prize on his own talk. That's right.
Yeah.
Wes O. I think Wes O was talking about the recording, so he might have bailed. Oh, no. Oh, there he is. Wes O's here. Yay. Okay. All right. So 1st prize to Wes O is JetBrains. Okay. That's it, everybody. So Calvin, could you post that link one more time? And then I'll just sort of hang on here for a while. And I'll go join the Calvin's meetup here. I'll just post that link here on the screen as well. So you can go check that out. Thank you again, Sean. Another round of applause for you for presenting with us and talking about microservices. Integer Man says, come on and join. There's Daleks. Is it Daleks or Daleks? Is it Daleks? I forget.
I've heard Daleks. I
don't know which one it is. I don't watch the Doctor Who, but I assume that's a Doctor Who reference.
Yes,
so you can come check that out there. We had a thank you from Hanson, 43206.
Yeah, thanks for the feedback. I really appreciate it, and thanks for coming out. I love giving this talk. I've done it multiple times, and I got several more to go. Um, and it's fun when you enjoy the talk and enjoy the technology stuff. So thanks for coming out. I really appreciate it. It's a good group.
Yeah, Surly Dev with a little clip there. He loves to troll me with these little clips.
Oh,
I'm
nice.
going to revoke his mod privileges. All
And
right.
being a user group leader as well, I already have ReSharper, and
I'm sure you do. That's yeah.
it's great.
Okay. So, I'm just going to hang out here awkwardly a little bit, I guess. But you're welcome. If you want me to take you off the screen, Sean, I can. If you want to go join the Meet group, I'm just going to hang out here for a second while people kind of wind down.
Okay.
And
Yeah, I'll go ahead and I'll jump over to the other link that Calvin gave, and I've got to be someplace else in just a little bit, but
okay.
I can join for a little while.
Okay, good. Cool.
Cool.
All right. Thanks, Sean.
All
I'm
right.
going to hang up the Zoom call now.
Awesome. All right.
All right, everybody. I really appreciate it. Next month, don't forget, we've got Rockford Rocky Laka talking about creating your business logic and running it and reusing it. So we definitely want to subscribe to Twitter for that. To see any announcements, Facebook, and certainly meetup.com. The details are already there for that next month's meeting. We're going to, again, proceed as if it's going to be online. I don't expect us to be meeting in person. I don't want to be pessimistic, but I just want to be sort of pragmatic here. So we're going to probably keep doing this. It may not always be me on Twitch. Keep that in mind. So you just want to make sure to go to the meetup and look for the details there, and just check it out and make sure you're in the right place at the right time. I'm going to get these prizes sent out, and I'm going to bring up the Calvins here in a separate window. I don't know if you'll be able to hear it on the stream. I said camera failed. That's because it's being used by Streamlabs. All right, y'all.
Or I can at Matt's here.
Yep.
Well, thanks everybody for joining. I'm going to go put on trivia to sort of just ease us out a little bit. And oh, you can hear their desktop audio, but you can't see them probably. Okay, I'm putting on trivia. Later, everybody.